The concept of enthalpy relates to the flow of energy during a chemical process. Energy can either be absorbed from the surroundings or released to the surroundings. We are concerned with two types of chemical processes. The first type is simply a chemical reaction or a chemical change. During a chemical change, intramolecular forces like covalent or ionic bonds are formed or broken. Breaking bonds requires energy from the surroundings, while forming bonds releases energy to the surroundings. Therefore, a chemical reaction can be either endothermic or exothermic. The other type of chemical process we are concerned about are phase changes. During a phase change, intermolecular forces are broken or formed. For example, when a substance freezes, intermolecular forces are formed. When a substance melts, intermolecular forces are broken. This means that phase changes can also be classified as endothermic or exothermic. The term endothermic means energy is absorbed from the surroundings. The prefix endo refers to energy flowing into the system. Thermic simply refers to heat energy. Endothermic means a flow of heat in to the system. If a chemical process is endothermic, then energy is a reactant. In other words, energy will be on the left side of the arrow in a chemical equation. The term exothermic means energy is released to the surroundings. The prefix exo refers to energy going out of the system. Energy is exiting the system. If a chemical process is exothermic, energy is a product. In other words, energy will be found on the right side of the arrow in a chemical equation. Let's look at the process shown here. Heat is added to liquid water and the product is water in the gas phase. This is simply a phase change. To convert liquid water into gaseous water, hydrogen bonds must be broken. Hydrogen bonds are intermolecular forces. This makes sense since liquid water turning into gaseous water is a phase change. Since heat is a reactant, the process of boiling or evaporating is endothermic. Let's take a look at this process. Here we have two reactants forming completely new substances. During the phase change in the last example, the product and the reactant was water. The only thing that was different was the phase, liquid or gas. The example here is clearly a chemical reaction because the products are completely different than the reactants. During a chemical change, actual chemical bonds are breaking and forming. The source of energy for this reaction is intramolecular forces. Notice for this process, energy is a product. It is on the right side of the arrow. Therefore, this process is exothermic. Remember that a good way to measure the heat given off during the reaction is to use a bomb calorimeter. Then you can make use of the enthalpy equation. Enthalpy equals mass times the specific heat constant times the change in temperature. In case you have forgotten what a bomb calorimeter is, here is a diagram of one. Remember, you can put your sample here and then combust it in the presence of pure oxygen. The heat released from the reaction will be completely transferred to the water inside of the calorimeter, which means your calculations should be much more accurate.